Okay, now I am going to help you solve a problem where all of the coefficients aren't the number 1. You can see here we've got a equation, Al plus Fe2O3, that's iron 3 oxide, yields iron and aluminum oxide. And it looks like at this moment there's a 1, a 1, and a 1, and a 1. But when you think they're all 1s, always double check to make sure you don't have some missing coefficients. So let's start with the first thing. I've got 1 Al, I've got 2 Als. So I immediately know that this is not a balanced equation. So right here, you put a big coefficient of a 2. And so now I have 2 Als. Over here I have 2 Fe's, and over here I have 1 Fe. So I'm going to go put in a coefficient of a 2 right there. So now I have 3 O's, and over here I have 3 O's. So this balances with a 2. There's a 1 there. If you don't see a number 1, you can put it there for stoichiometry purposes. We generally don't put it there when we're balancing, but it's a 2, 1, 2, 1 is what your coefficients are. And you're going to need them to plug it into the coefficient portion of your stoichiometry template. So I'm going to do this one example. I've done all of part 1, but this one had a problem where you had to balance the equation, so I was going to show you that one as well. So we're going to go ahead and solve B, 2B, because it makes you look up some molar mass. So we're going to go ahead and solve that one. So 2B, every problem that you do that is a stoichiometry problem starts with the stoichiometry template, which is your 3 locations to put your information with multiplies between them. In this first spot, it is the number that is given in the problem. So if we go back up to problem 2B, it's 75 liters of iron 3 oxide. That is the given information. So 75 liters of iron 3 oxide. So on the line, I'm going to write 75 liters of Fe2O3. So that's one thing we're going to definitely fill into the problem. The other thing we're going to fill in immediately to the problem is, well, what are we looking for? And that's what we're trying to find. So we're trying to find grams of Fe. So right away, at the back of this problem, I'm going to say that I am trying to find grams of Fe. That way, it will remind me, as I'm going through the problem, what it is I'm looking for. Every time in a stoichiometry template, there's a number 1 right there. And so then you can go ahead and fill that in at any time. So here's my setup. I've got 75 liters of Fe2O3, and I want to solve for the number of grams of Fe. So I'm going to set this paper down and show you what you plug and chug, and hopefully it stays in focus. Okay, so I've got 75 liters, and if you have liters, if you've been given liters, then underneath it you put the number from the box, which is 22.4, 4 liters. So that's going to be 22.4. In this location, it is the coefficient of what you're trying to find. So what am I trying to find? I'm trying to find grams of Fe. So I come up here and I want the coefficient off of the Fe. So that is where I'm getting the number 2. This is the coefficient off of what I was given. And that's why I wrote what I was given. I was given Fe2O3. So I come up to the problem and I find the Fe2O3. It's right here. And the coefficient on that is a number 1. So that's where I'm getting the number 1 that I'm putting right here in my problem. This, in the template, is what I am trying to solve for. So I'm trying to solve for grams of Fe. Whenever you're solving for grams, that's when you have to look up the molar mass. The molar mass of what? Fe, because that's what I'm looking for. So on the periodic table, I find Fe, and you look at the number that is here in red, and it is 55.8, and you round that. It's kind of hard to see because of the glare, but it is 56 is what we're going to round that to. It's 55.8 if you'll be looking hopefully at an actual periodic table and not this one with the glare. So that's a 56 grams. So in the spot on the template, that one was a pretty easy one because it wasn't a whole bunch of formula. It was just the one problem of Fe. But if I was looking up something else, I'd have to look at the subscripts and everything to get the numbers. So now my problem is going to be 75 times 2 times 56. I hit my equal sign then. I hit divided by 22. So let me plug that into my calculator. So there's only one number on the bottom, so I won't need to put anything in parentheses here. So it's just 75 times 2 times 56, and then divided by 22.4. And I end up with getting 375. So 375 grams of Fe is how many I could produce if I'm given 75 liters of iron 3 oxide. Hope it helps.